Hi guys, this is Mark. In this video, we'll talk about one-to-many relations. We discussed it briefly in one of the previous videos, and we identified some examples of the one-to-many relation, those where person and parents, or country and cities, or we had customer and orders. So those are pretty good examples of the one-to-many relations. Indeed, unlike one-to-one relation where we have one entity related to another entity in a one-to-one correlation. With one-to-many, it's pretty clear that for one entity of one kind, you have a collection of other related entities, just like we have, for instance, with country and cities, where country would be in the country table and cities would be in, and then all the related cities would be in the city table. Creating a one-to-many relation in Backendless works just like with one-to-one relation. The difference is that when you define the cardinality, you would select one-to-many. I have put together a sample database that I recommend you importing into your application, and it will have a pretty good demonstration of the one-to-many relations. I already have this database installed, but just to give you an idea of how to do this, you have already done it in one of the earlier lectures. To import data, you would need to go to the Manage section. Here you select Import. Download the zip file that is referenced in the description for this video. And once you have it on your computer and you are on the import screen, click the Browse button, select the zip file, and click Import. It will take about 50 seconds to import all the data. It has about 40,000 records in one of the tables and about 240 records in the other tables. And what you will end up with will look something like this. So you will have the country table that has 239 records, and you will have the city table that has a little bit over 42,000 records. And then the schema is defined like this. So in the country table, if you go to schema, you will see that there is a relation column called cities, which is a one-to-many relation to the city table. So what this means is that for one country, you could have a collection of cities that are located in that country. By the way, as far as creating that column, I just described it, but if you were to do it by yourself, in the schema section, click New, give it the name of the column, and then in the data type, select Data Object Relationship, and in the cardinality, select one-to-many. Whatever the related table is, that will be the child table that will contain multiple records correlating to one record in the table that you are in. Very, very straightforward. So with this schema and with this table, what you will have is for every country, there is going to be cities column. And then as you can see, for one-to-many relations, the first of all, the visual indication are three red dashes here. So that's going to be one-to-many. If it is one-to-one, you will see only one red dash, one red line. And in here, whenever you have relations established, the actual link, when you move the mouse over, will tell you how many related objects are for the record where that link is at. So for instance, if we take Argentina, then we will have 319 related cities for Argentina in that specific database. If you follow that link and click on it, then console will display all the cities for the country where you were navigating from. And here it shows the count of all those cities, so you can start inspecting this data. In this lecture, I will talk about primarily just importing this data, kind of navigating through and seeing how it is organized. And there is one other consideration that I will bring your attention to whenever you are setting up a one-to-many relation, as far as retrieving data, managing those relations, creating, deleting. There will be separate videos that focus on the API. But right now, it is really just the conceptual understanding of one-to-many. As far as adding additional records to a relation, it works exactly the same way as with one-to-one. So for the column that is a one-to-many column, if you need to manage the related objects, just click this icon right here. This pop-up opens up. It will show you all the cities that are already in the relation, and then all other cities that are not in the relation would be available through this radio button. So if you click on this, it will show all other unrelated cities. It doesn't make sense to add cities because they belong to other countries, but in your case, if you have your own schema, then just selecting records and clicking update relations will add the selected objects to the existing relation set. It will just be expanding it. Or if you need to remove some records from the relation, then on this in this section where it says show only related objects, just deselect whatever records you want to remove from the collection of related objects and then click update relations. In fact, when you move the mouse over, the tooltip says 4 objects will be removed. It doesn't mean that the actual objects are deleted. So what happens is the actual link between that country in this case and those related cities, that link will be removed. The cities will remain. It's just the linkage is removed. So whenever you manage those relations, the actual objects are not deleted. You either build the links or delete the links between the related objects. That's all. Now, let's talk about the actual relationship of one-to-many whenever you're going through your design considerations. And that is something that is very important. And for this, I will go back to the example of customer and orders, because we already looked in the previous video, in a couple of previous videos, we discussed one-to-many relation where one order was related to a customer. But as we discussed early on in this lecture, I mentioned that a customer could have multiple orders. So this is something that I would recommend whenever you go through the design phase for your application, for your data model. This is something that would be very important. I'm going to switch to a slide. So here we have a schema where the customer table has a relation, a one-to-many relation to the order table. And it's fairly straightforward. That's how it should be, you could say, right? But let's consider another alternative. And it may look a little odd at first, but trust me, it will make perfect sense. So another alternative could actually be order pointing to customer, which is a one-to-one relation. And you could say, well, how could this be a one-to-many if it is one-to-one? Well, it can, because if you think that if you can imagine that multiple orders could reference the same customer, then from the reverse perspective, from the customer perspective, there are multiple orders pointing to that customer. And we know that in backend lists, all relationships are bidirectional. And that is also true for one-to-many. When you have multiple orders pointing to the customer, when we do reverse lookup, from a single customer, we can find all the orders that are pointing to the customer, which means that to implement a one-to-many relationship, you actually have 2 options: the classical one-to-many, as it is shown at the top, or an approach where you use a one-to-one relationship. And in your implementation, you use the reverse lookup to go from child object, in this case customer, to find all the parent objects, in this case orders. However, whenever you have a situation like this, and it doesn't happen for everything, like for instance, in a country and cities relationship, the one that is at the top, I think, makes perfect sense, and you will see why. But I'm kind of getting ahead of myself. But let's just go through the analysis to see why one would be better than the other. And this is how this analysis I recommend to go. So consider that you have this kind of schema where you have classical one-to-many, where from the parent table customer, you have a collection of related order objects. In this case, the analysis goes like this. You would look into what it would take to create new child and what it would take to delete a child. In this case, to create new order, it will require 2 API operations. One is you would be saving the order, and second, you would be establishing relation in customer. Remember from the video where we establish relations, you send that API request to the parent table, so the table that actually has the relation column. In this case, child object is saved, and then you update the parent object to add that new child to the collection of related objects. So two operations. And then as far as the delete, then you would just be deleting the order and backendless automatically cleans up the relation. Okay, so you don't need to do anything with relationship management. Backendless takes care of that. So that's what we have with this classical one-to-many. Let's see what happens when we have a one-to-one, where order is the parent table and it has a relationship, a one-to-one relationship column to the customer. Well, things look at first glance almost the same, where we have two operations where you save the order and then you establish relation to the child, meaning the customer, in the order object, right? Because in this case, order is the parent. And then as far as the deletion, you just delete the order and then that link is automatically taken care of by backendless. So at first glance, they look exactly the same. In fact, when we compare them by side, they look almost identical in terms of the operations that it take to manage those relations. However, let me point out a slight difference between the two. So the slight difference is going to be here. Notice that in this, the classical one-to-many, we are saving order. So we work with the order table and we're updating relationship in customer. So we are working with two different tables in this case to make these two operations. In this case, we save order and we establish relation in order, which means that we're targeting exactly the same table. What you will learn later in this course is that in this case, optimizing this would be a lot easier because there are various ways in backendless when you can actually group these operations into one. It would still result perhaps in two different API calls. However, from the client-side perspective, whenever you are requesting backendless to create this relationship, saving the order and creating the relationship with the child could be optimized where it would result in less logic that you would need to create or less code that you need to write. And as a result, this specific option in this case would actually be the preferred one, the one that will result in less code to write. Not so much maybe better performance. The performance will be about the same, but in terms of the productivity that you get, your own productivity to create a solution, this approach would be better. That is something that is very important to keep in mind whenever you work with one-to-many relationships. Now, from that perspective, going back to cities and countries, new cities are not created very often. As a result, it's more of a static kind of structure where you have country with a collection of cities. In this case, classical one-to-many relationship would be the way to go. However, for other systems where there is a dynamic nature of one side or both sides of the relationship being created and deleted, I would recommend going through this exercise to understand which one would be better for your application. There is a lot more to come as far as the relations. We're just scratching the surface. A lot of APIs that are related to relations. So stay tuned. A lot more cool stuff is coming. I hope this video was useful. Thank you for watching. And as always, happy coding.